Well, hi folks, we're continuing our discussion about lighting for the next 20 or so minutes. We've got Peter here from Photon Beard, and Alan's agreed to stay around as well. Photon Beard, manufacturer of the traditional redhead, I guess, had a big shift this year. Peter, tell us about what you've been doing.
Well, I mean, we've been making redheads arguably since the very first redheads. There's arguments about who had the first redhead, but we think we've got a pretty good claim, being 132 years old. But this year we've launched an LED redhead, something that the market has been looking for. We're quite late to the LED lighting market for a whole host of reasons, but which I'm sure have been covered elsewhere. But remote phosphor, which is the technology we've used in here, brings a whole new quality of light to our arena, and it's the first time that I've felt possible to put our name behind an LED product. And we started with a redhead because it's small, it's portable, and we can try the technology and adapt it. So what we've done is we've got our traditional redhead housing here, which most people will recognise from years ago. It uses standard barn doors that you'd find on any redhead. But the big advantage is it being remote phosphor LED. It can be battery powered. So if I turn that on, I won't point it at the camera. You can see, it's a nice quality of light. It's dimmable there, and I'm sure people will have seen that was a daylight light there. But the great thing with remote phosphor is you can change the phosphors. You can just, of course, now it's been difficult. And inside there is the actual phosphor disc, which looks like that, and that's what actually produces the light output. That one in there is a daylight phosphors. This one is a tungsten phosphor. So if I put that in and switch it on, you would get.
So for anyone who wasn't here for our earlier session, just explain what remote phosphor is.
The way that, as I understand it, the way all LEDs work is that the light that's produced at the junction of the diode is a blue light, and that blue light excites phosphors that are embedded in the glass around that junction. The problem with trying to embed the phosphors in something that small is getting accuracy and repeatability is very difficult. You're working in a very small space. With remote phosphor, you're actually putting the phosphors on this glass disc, and you have a much larger area that you can get repeatability and accuracy. So the LEDs that you can see in there are producing a blue light, and this sits about 20 millimeters in front of those, and the blue light excites the phosphors and produces the light output.
The concept of a blue LED lighting up a phosphor is absolutely crucial. That's what all LEDs are about. The blue LED is gallium nitride, for which the guy who invented it got a Nobel Prize this year. So it's quite significant. It's by far the most efficient form of source of light electronically. It has to be a blue light source because of some work done by a British physician called Stokes, physicist called Stokes, in the 19th century, who was investigating the light output from the algae in the oceans, why they glow green in the dark.
Okay.
What he found was that there are some materials which, if you hit them with a source of energy, will re-radiate that energy, but at a different wavelength, different color. What he found was that those two wavelengths cannot overlap. There is a gap between them, which is the gap that you see in all of the standard curves. I'll show you a typical example. No, not that one. Or that one. That one. There you go. There is the gallium nitride diode, and there is the phosphorus. There is always this gap in between. Now the problem is filling that gap. Now if you have a set of diodes with the phosphor directly on them, there's nothing you can do about it. But there's a trick which you can play, which I don't think anybody has played yet, which is that the blue diodes in there don't all have to be the same blue.
Right.
If you had, say, 2 or 3 ultraviolet diodes in there, you could fill that gap up.
Okay.
And that would improve the performance dramatically. Might be expensive because ultraviolet diodes are expensive.
It's something we would certainly like to try.
I will sell you that idea for nothing.
There we go. You heard it here first.
Indeed.
So tell me more about this technology, Peter. I mean, how long has it taken you to get here? Where are you at? Is it available now?
It's taken us almost a year. We first the first prototype at NAB last year, but it was very much shoehorned together. Sort of 2 days before we flew to the show, we finally screwed it and flew. So it's taken us about a year to get everything working absolutely perfectly. One of the areas we spent a lot of time on is finding the right fan. Sadly, with all LED products in this size, it's very difficult to remove the heat that comes out the back of the LED with any other method other than a fan. You know, you'd have to have a pretty big heat sink on there. So we spent a long time trying various fans. We believe we've found the quietest possible fan we can. Simon, our technical director, could give you all the specs as to exactly what it is, but certainly when the unit is running in a quiet room, you have to put your ear up to the housing to actually hear the fans running. So that took us quite a while, but we're now in full production. We've sold, the first batch has already been sold. We have something like 12 lights went out to Star Sports in India for use on the Cricket World Cup. A customer in Malta has half a dozen in their studio. They're using them as a key light. Their studio is on 24 hours, 7 days a week. It's an online casino. And they just wanted a light that once it's set, it stays on all the time. And this is actually lighting the dealers. And unlike a lot of LEDs, this is much more of a harder source than most LED products. So you're getting some nice shadows from it, which again is one of the things that's missing from a lot of LED products.
Yeah.
The LED panels are just an array of lots of point sources, and you get multiple shadows.
Yeah.
It's a hard light, which you then try and soften by putting some diffusion in or something like that. You start to lose light output immediately. So that's another big advantage with remote phosphor. You know, you're starting with a fairly small source. Obviously, we have plans for other remote phosphor devices, and as they get bigger, then they will share some of those disadvantages. But it'll be interesting to see, because I think the way it works, because this is actually your light source, it's not the LEDs that are the light source, this is your light source. So actually it's a soft light right from the word go.
And who traditionally, I mean, the traditional redhead for me is not something I've used for a long time because cameras have become so much more sensitive. So who traditionally is using these kind of fixtures nowadays?
The redhead and the blonde, I mean, I should talk about the blonde as well. For years, the traditional sort of workhorses of outside of a studio has been the redhead and the blonde. The redhead is an 800 watt tungsten unit. The blonde is a 2 kilowatt tungsten unit. And they got their name because of the colouring of the housing. Yeah. And most people will be very familiar with redheads and blondes. They have been the stable workhorses for ENG lighting for 40 or 50 years. So, and even to this day, we still sell quite a lot of the tungsten units because as a light source, it's one of the few things, there's nothing in front of the light source there. You can get as much light out of there. So you might bounce that off the ceiling, or you put a softbox on the front to soften it. As soon as you put anything in the way of the light, you start to lose light output. So the less you can do, the better.
And what's the comparable output from this? Is it comparable to an 800 watt redhead?
No, it's about half the light output. A traditional tungsten redhead would be 800 watts. This is giving you similar sort of light output to a 400 watt.
Which is still pretty significant.
Still pretty good. What we haven't done yet is, one of the problems with a traditional redhead is it's tungsten. So it's 3,200 Kelvin. If you want to use it outside, you have to blue it up. You have to put some gel in there. And again, producing the blue light is one of the most inefficient ways. So as soon as you put some CTB in there, you lose light output. And I think when we measure this against the traditional redhead with CTB in there, it will actually be the same.
Yeah, or even better.
Same or maybe better.
Yeah. And is this a tungsten filament? Is this something you can just swap out?
Yeah, it's actually it's difficult to tell. So I couldn't definitely say that's a tungsten one because it's difficult to look at and say what the difference is.
You can't tell just by looking. You have to try it.
Do you have? But presumably in a kit, there's a tungsten and daylight option.
Yes. I mean, we're selling it as it comes as standard with the daylight phosphors in there. If you want, because we think most people are going to want it as daylight because traditionally they're used outside. Yeah. But if you want to have tungsten or you want to have the option, then you can buy that as an accessory, and that is only £60. It's you know, it's not a lot of money. Yeah. The value is more in the rest of the housing. Yeah.
So Alan, you've tested this yet?
Yeah, it scores really well. It's up with the best.
Yeah. And is someone like Alan who's out testing lights useful for you as a manufacturer?
Absolutely, vital in fact. I mean, as a manufacturer, we can sit here and we can tell you how wonderful this is, and you know, this is the best light you've ever seen and you'll never need anything else. But of course I'm going to say that because I'm the manufacturer and I want you to buy it. Yeah. Somebody like Alan who's truly independent and is testing everybody's light, and giving no quarter. You know, if you score badly, he'll tell you score badly.
Yeah, certainly
if you score well, he'll tell you score well. So it's actually very valuable to have somebody like Alan.
Do you think we should put him forward for a knighthood or an MBE or something? It's kind of like, you know, this. You just quietly get on with it, Alan. The stuff you do is so vital to the industry.
I have no axe to grind with anybody on this. Fundamentally, I do not give a hoot for any of the kit in this building. I'm not really all that interested. Yeah. What I'm interested in is how good the pictures are on my TV set at home. Yeah. And anything I can do to maintain the standard or improve it, I will do. Yeah. That's what this is about.
I agree. Well, listen, guys, thank you very much indeed. Really interesting. Congratulations on getting this out, Peter. I've seen you over the last couple of years, been trying different technologies, and it's great to finally see you get it right. Alan,
and I can't compete on the hair in the hair front.
That's it, you know. Well, guys, thank you very much. We're now going to hand over to John, who's out and about.